Yeah, I hope we are all fine. And before we go into the lesson, I'll request someone to raise their hand so you can lead us in another prayer. Yes, Michael.
Let us humble
Ma-
ourselves and we pray.
Mhm.
Heavenly, are we together?
Yes, you can go.
Okay. Let us pray. Heavenly Father, Lord, I want to thank you for this wonderful time you have given us. I want to thank you for your protection, for you have protected us since the day of our birth up to now. You're still protecting us. Father, right now, as we're coming to start our lessons, may you bless our teachers. May you make us understand all that we're coming to learn. For I pray all this in the name of the Father, the Son, and the Holy Spirit. Amen.
Amen. Thank you, Michael.
You're
And
welcome.
yeah, so once again, you're all welcome and taking you to taking you to today's lesson is Chamaka, and I've seen most of us, we have varying topics, but our plan this year was we move on to a topic, the first topic in the class you have moved to. So probably if we are lagging behind, we'll be able to catch up with that when we go back to school. So this afternoon we'll be looking at our first topic in senior four, and congratulations to all of you on getting into the next class. So, who has a clue on what our first topic in senior four is? Anyone with an idea? And since this topic is new for everyone, at least all of us will be able to contribute and share at the same level. Okay, someone is saying no idea. Okay, anyone else who has an idea on what they think our topic is? Okay, industrial processes. That's a good trial. Though it's not our first one, but at least it's a senior four topic. Okay, so today we'll really look at oxidation and reduction. I don't know if any of us have heard about those two words. We'll be looking at oxidation and reduction. And as you can hear the words, it sounds to be a very interesting topic if you pay close attention and contribute as well. All right, so we'll be having some keywords in this topic, and I'll request someone to unmute and read for us the first set of new words that we'll be looking at in this topic. Yes, Jesse. Jesse.
The
Rosemary, you can
keywords
help
we
me.
have:
Mhm.
anode, cathode, conductor, electrode, electrolysis, electrolyte.
Okay, very good. So we are going to interact with the anode, cathode, conductor, electrode, electrolysis, and then electrolyte. Then I'll request someone else. I can see Salma's hand is up to read for us the next set of keywords.
Alma's hand went down. See. Patience.
Oxidation, oxidation number, oxidizing agent, redox reaction, reducing agent, reduction.
Okay, thank you, Patience. So, of course, we will not define these keywords now, but as we go into the topic, we'll keep meeting some of these and we'll keep drawing more light on what they actually mean. So, as we go through the lesson, have these keywords at the back of your mind. If you can take a screenshot and keep referring back, the better. But we'll keep defining those keywords as we come across them. Okay, then we have electrolytic cell and then ore. At least you've heard about some of these, so it will not be very hard. So we also have the competence in this chapter. Can someone unmute and tell us and read for us what the competency is? Because for every chapter you realize we need to know what the competency is so that we are able to know what we are learning and put emphasis on those things that are important.
Bakita. Bakita, we can't hear you. Okay, let's hear from Salma.
Competency. The learner understands oxidation and reduction in terms of gain or loss of oxygen and in terms of electron transfer, and he or she appreciates that the two processes always occur together. Hello?
Okay, thank you.
You're welcome, madam.
Then we also have the learning outcomes. Just a minute, someone is complaining that my answers, my letters are too small. I hope this can help a little. Okay, so let's have someone else also read for us the learning outcomes that we are going to use.
Rose Jolly.
The learner should be able to understand the processes of oxidation and reduction and their importance in the chemical industry. Explain redox reactions in terms of electron transfer. And understand the changes that take place during the electrolysis of some compounds. Yeah, that's it.
Okay, thank you. So during redox and oxidation reactions, we are going to be able to understand the processes of oxidation and reduction and their importances in the chemical industry. So if we are having oxidation reactions and reduction reactions, how are they important? Then also to explain redox reactions. The people who are lost, I don't know why you're lost because we've not yet even started that topic. So I don't know if you just chose to get lost or you just feel like getting lost. We are still introducing that topic, and we know that in our curriculum, we need to understand the competence, the learning outcomes, and the keywords that we have to interact with during the topic. So just focus and you'll get there when we start the actual terms. So we are also going to understand the changes that take place during electrolysis of some compounds. And these are all practical subjects, so we will see as we move on. Okay, so I have some discussion questions for us here that we'll be looking at. I don't know why I wrote shape here. This one is supposed to be, why does a spade turn brown when exposed to damp air? Who has a clue on why a spade turns brown? So the lesson has actually begun. So as we brainstorm on some of these questions, you'll start to understand some things. So why does a spade turn brown when exposed to damp air?
Shaba.
Okay, for the damp air, it contains the oxygen and the moisture. So in the process, it undergoes rusting and it turns brown.
Okay, that is good. Thank you.
In the chat, Treasure says Nancy says due to rusting. Oppo says it rusts. Treasure says the presence of oxygen and moisture. Then Saida says due to presence of oxygen.
Okay, good. Those are all beautiful answers. Thank you. So when you're looking at that fact that if a spade turns brown when exposed to air, and all of you are telling me about oxygen, that brings out what we are actually going to be looking at, because we are going to look at oxidation reduction. So as we look at those things, we are going to understand why a spade actually turns brown in the presence of what? Of oxygen and moisture. So these are some of the things we are going to relate with. So these questions are just to open up your mind that actually this topic is very easy and it deals with the things that you interact with every day. So those were good answers. Then we have a second question here. Why do fresh fruits like bananas, pineapples, avocados, oh God, and apples, this one here was supposed to be apples. This one here, and apples, why do they turn brown when cut and exposed to air?
Okay, apart from Shaba, any other person? Priscilla?
Can you hear me?
Yes.
This is because oxygen is introduced into the plant's tissue and oxidation takes place.
Okay, thank you. That's good.
Chiravo Hannah in the chat says oxygen in air reacts with the fruit. You see?
Okay, that is also good. So when we are looking at those fruits, and I know most of us have cut those fruits, and when you leave them before you eat them for some time, especially the common one is the apples, when you leave them exposed to air for some time, and then the bananas, the avocados, you realize that they start to have a brownish coloring. So that brownish coloring is as a result of oxygen in the air reacting with the fruit, and then you're able to get that brown what? Coloring. So basically, that is what our topic today is all about. Okay, so please, those that are copying down these questions, you make those adjustments. This was supposed to be a spade, and down here it's apples. I think I'll correct that. And then I'm seeing a hand up. Is it a question or an answer?
Alan?
Excuse me, teacher.
Yes, please.
Teacher, for me, remember I've just joined the Zoom class right now. So teacher, I've not understood that topic. Even I don't know what is going on in the group. So I've not understood number 1 and number 2.
Okay, Alan, these questions are for you before we go into that topic, because our topic is really centralized about these questions. They're just to open up your mind. We've also just started. Why does a spade turn brown when exposed to damp air? What do you think?
Alan, your hand. Where are you?
I think let's hear from someone else. Even though it's not her,
Okay.
maybe she can follow up.
Han,
Can you get me?
yes.
Are you getting me? Should I answer her?
Yeah,
Actually,
Please do.
go ahead.
Madam was like, the reason why the spade turns brown when exposed to damp air is due to the presence of oxygen and the moisture. I hope she has got it.
Okay, thank you.
Teacher Martha in the chat, Deogracious is asking, does it turn brown after being cut or when it's still whole?
How many of us have seen apples? Because before you cut an apple, you will never see the brownness. Of course, you'll have to first what? Cut the apple or peel the yellow banana or cut the pineapple or cut the avocado. So these things happen after you cut these fruits. That's why the question is saying, why do they turn brown when cut and exposed to air? So basically that happens after you have cut them, and then they are able to react with the oxygen that is in the what? In the air. So today, as we go about our topic, I want you to have these two questions at the back of your mind and why they are our starting questions at this point. Yes, Patience, your hand is up.
Yes, I have a question.
Yes, please.
So why is it that there are some fruits like apples, when you cut them, they immediately turn brown? But then there are these other fruits that take some time to turn brown. Why is that so?
So we are going to look at that as we go through the what? Through the topic. You realize that some reactions are fast while other reactions are very what? Are very slow. So you realize that brings about the slow changes. So for an apple, you may find that the reaction between the fruit molecules and the oxygen is fast, yet for a pineapple, they are what? They are slow. And that is why it will take long to what? To form. So basically, it's about their rate of reaction.
Jesse, your hand is up.
No, I was just giving an idea I have on what she asked.
Okay, you can still go ahead.
For me, I thought like these different fruits have different like elements and different concentrations. So you may find that an apple has a different concentration of those elements that hence they react faster, causing a faster browning than in other fruits.
Okay, that is good. Thank you, Jesse. Okay, Ruth, are there any other questions maybe in the chat, or we can proceed?
Robin is asking, in the fruit, what does the air react with exactly?
You realize that all those, everything in everything within our environment is made up of molecules. And those molecules, of course, we've understood the dynamics in chemistry, what a molecule is, what an atom is. So you realize that if they're made up of molecules, for example, when you find fruits, most fruits have a component of citric acid. What makes up citric acid? What are those molecules that make up that citric acid? So you find that at least every fruit has molecules which the oxygen reacts with, and it is able to form that brown what? Coloring. Like for example, if you go to the spade is made up of iron. So when you look at the spade, the iron is going to react with the what? With the oxygen to give you the rust that you see eventually, or even the corrosion that you see at the end of the day. So basically, everything in the world is made up of molecules and atoms or something, at least it has a chemical composition in it. Okay, there are people saying my
Then
volume is low. I don't know how to make it louder, but I think I am screaming where I am surely.
then some are associating it with the acid that is in the apples.
Yeah, I think that's what I've mentioned. So really, you have to associate it with the molecules that make up the apples and what chemical composition is there. Okay, I request that we move because we've dwelt here for some time now. Okay, so here I'm going to request us to note down some of these things or even take a screenshot because I'll keep referring back and I don't want to keep moving back to the previous slide. But for us to follow closely, you'll just have to take a screenshot or copy down these equations a little bit faster. Because I'll keep referring to them with the questions in the next slide. So we may need to really have them. So we have these reactions. And of course, the first reaction, we are burning sulfur in air to form sulfur dioxide. And you can see we have sulfur here. We have sulfur here. This is sulfur burning in oxygen. That means it's reacting with oxygen to give us sulfur dioxide gas, which looks like this. And then we have heating of copper metal in air to form copper 2 oxide. So we have the copper metal, which is brown, burning in oxygen to give us a black solid of copper 2 oxide. So we also have another one here. It is saying exposing nitrogen oxide to air to form nitrogen dioxide. So we have nitrogen oxide, NO, reacting with oxygen gas to give us nitrogen dioxide gas. And then we have reacting chlorine gas with methane to form chloromethane. So here you have methane. I know we've done organic chemistry, so this shouldn't be new. Plus chlorine gas to give us chloromethane and hydrogen chloride gas. So you realize that in this, I want you to note something about the first equation, the second one, and then the third one. What do you notice about those first three equations? Who can tell us what they notice about those first three equations?
Michael?
what I see about these equations, number 1, 2, and 3, is that all of them have reactants, that all of them have oxygen as a reactant.
Okay, that is good. Thank you.
Then
That is a good observation.
from the chat, Nicole says they are oxides. Tessa says they are oxides. Mona Treasure says solid react with a gas. Oppo says all react with oxygen. And then Bridget says one product, I think, is formed. Chirabopal, oxygen is being added to the solid to form a new product. Rhea, they are forming oxides, react with oxygen to form oxides. From Tracy, they are metal and non-metal oxides. Then are Hirat,
Okay.
I think in the first and the second equation, there is burning of a substance.
then Pershi,
My question is that I wanted to say the same answer.
Watifai also say that the product formed is a diatomic substance, diatomic molecule, because sulfur is dioxide, then copper is 2-oxide, and then nitrogen is dioxide. Do I be correct?
Okay, now when you're talking about the atomic molecule, remember, molecules exist as elements. Because now when you look at these are all what? Compounds.
Compound.
Yes. So that may try to bring it out, but it doesn't really articulate it to what it actually means.
Okay,
So
thank you, teacher.
okay, thank you all for your suggestions, and thank you, Ruth, for taking us through that part. So you realize each of these three equations or reactions, we have oxygen being added to every one of these first elements or compounds. So you realize that here we are adding oxygen to sulfur, we are adding copper to oxygen, we are adding oxygen to the nitrogen oxide. So that helps you understand that in this case, you realize that all those reactions, we are adding oxygen, adding oxygen, adding oxygen. So I want you to keep that at the back of your mind as we navigate through this. And then for the fourth equation, what do you notice about the fourth equation? Who can tell us what they notice about this fourth equation?
Priscilla? Okay, Priscilla's hand has gone down. Michael?
I think for the fourth equation, it is a gas reacting with a gas to form one product, because chlorine gas is reacting with methane gas.
Okay. Itel?
According to
What's your name?
me, the first I'm saying according to me, the first equation is a reduction reaction because there is interchanging of chlorine, so that is a reduction reaction.
Okay.
Okay.
What's your name, please?
I'm called Chan Kenneth.
Okay, thank you, Chan. Xperia?
I think equation 4 has a gas, contains a gas and methane.
Okay, teacher, also in the chat, let me see. Navakoza Joan says they are gases with liquids. Mona Treasure says no oxygen is being added to react. Then according to me, I also see that chlorine was split. In the product, we have one chlorine this side in the chloromethane, and then another one in the hydrogen chloride. So it was split. Then Atapito Twister says they are liquid gases. Travel Pal says chlorine was reduced. Chlorine is reduced.
Okay, thank you. I didn't want us to use those terms of reduced as per now because we'll confuse the rest of the people. So I want us to flow on the same page. So you realize that here, unlike these ones where we're adding oxygen to the substance and then we're forming oxides this side, when you come to the fourth reaction, you notice that one of the hydrogen was picked from methane and it formed hydrogen chloride. And then the other hydrogens which remained also formed the what? The chloromethane. So in this case, you look at chlorine taking away one of the what? Of the hydrogens from the methane. So I want us to keep that at the back of our minds, that chlorine is taking away one of the hydrogens from the methane to form hydrogen chloride gas. Okay, so at that point, there is another equation I want us to see. I think by now people must have taken the screenshot. So here we have also another one where we are exposing hydrogen sulfide solution to air for a few days to form sulfur and water. So still here, much as we are adding oxygen, you notice something, that hydrogen, the oxygen takes away the hydrogen and sulfur remains what? Alone at this point. So here you notice that the hydrogen is being taken away by the oxygen to give us water, and then sulfur will remain alone as sulfur. So in this case, when you look at these equations, when we are talking about oxidation and reduction, which of the two do you think is happening in these reactions that we've just looked at up there? On oxidation and reduction, which one do you think is taking place in these 5 reactions that we are looking at?
Bridget?
I think it's reduction.
Okay, thank you,
Did you
Bridget.
get me?
Thank you, Bridget. In the chat, Chirabo Paul Hannah says in the first 3, oxidation because oxygen is added. And then let's also hear from, okay, then Paul Hannah still adds that in the last 2, it's reduction. Then Josephine is saying both. Robin,
Yes, you're saying in the first 3, 1, 2, and 3, we are having oxidation, a component of oxygen being added, and then to 4 and 5, there is reduction.
Okay, thank you. Okay, so after understanding those reactions, who can tell us what oxidation is? Who has a clue? Who can tell us, if I asked you what is oxidation, what would you tell me?
Atugonza Joel.
Oxidation is the addition of oxygen to a given element or a substance.
Okay, that is good. Thank you.
Jesse?
Oxidation is the removal of hydrogen from a given substance.
Okay, good. Thank you.
Shaba?
Oxidation is the removal of electrons from a substance or loss of electrons.
Okay, that is good. Thank you.
Ategeka in the chat says that oxidation, oxygen is added while hydrogen is reduced. Then Paul says oxidation is addition of oxygen to a substance to form something else like an oxide. Nora says oxidation is the removal of hydrogen from a substance. Lastly, Katrina. Katrina, you've not unmuted. Let's hear from, let's see, Kenneth.
Oxidation, to me, how I understand is that oxidation is the addition of oxygen into another element.
Okay.
Okay, thank you. I think we can go with that for now. So thank you all for sharing. When we are looking at oxidation, the same way you hear the word oxidation, that means it comes from oxygen, oxidation. So you're looking at addition of oxygen, but like I showed us, we had 5 equations. If you had written down, you can go back and refer. So the first 3 equations, now it's a please kindly don't write on the screen. So when we look at the first 3 reactions, we had adding oxygen. So you notice that that one can quickly direct you that that is an oxidation reaction. But also oxidation reactions involve removal of hydrogen. So in instances where we have not added oxygen, but hydrogen is being removed, it therefore becomes an oxidation reaction as well. So when you're looking at oxidation reaction, so when you look at these last 2 equations, the 4th equation and then this 5th equation, you notice that hydrogen is being removed from hydrogen sulfide, and the other side we saw that hydrogen is being removed from methane. So in that case, those are also referred to as oxidation reactions because they involve the addition of oxygen and removal of hydrogen. I don't know if we are together up to that part. So for the first 3 equations, oxygen is being added to the substances. And then for the last 2 equations, hydrogen is being removed from the substances. So that is still referred to as an oxidation reaction. So that means all the 5 equations we've looked at up there, they are all oxidation reactions. So may I get someone to read for us the definition of what an oxidation reaction is?
Teacher, before someone reads, I have a question about the definition. Can we put or instead of and so that we have oxidation is the addition of oxygen or removal of hydrogen from a substance?
Yes, that's very okay.
Okay. Wycliffe, your hand went down. Enid,
Oxidation is the addition of oxygen and removal of hydrogen from a substance.
So we can adopt the word or. But like in this last equation, you can observe that oxygen is being added to hydrogen and hydrogen is being removed from sulfur. So basically, you just need to note down that it's the addition of oxygen, whereas it can also involve the removal of hydrogen from a what? From a substance. Those are very key things to really take note of. Okay, do we have any questions, or we've understood that bit of oxidation? Because of course, about the loss of electrons, we'll look at that later. But for now, I want us to understand these different what? Reactions. Are we all good? Can I get some feedback, please?
From the chat, people, okay. From Cynthia is saying yes. Yeah, Nicole, okay, the feedback is good. Then the hands that are up, Bridget, do you have any question? Shaba or Linda? Or else you can lower down your hand. Okay. It's okay, teacher, you can move on. Deogracious, your hand is up. Okay, it's okay.
Okay, thank you. So, now next part, I want us to look at the next slide. So here we are still looking, after understanding what oxidation is. What is an oxidizing agent? If I say an oxidation reaction is taking place, that means there should be something that is causing that oxidation to take place. So what is an oxidizing agent? According to what we've understood about oxidation reactions.
Yes, sir. Yes, sir. Unmute. Endo.
According to me, an oxidizing agent is a substance that adds oxygen or removes hydrogen from another substance.
Okay, that is good.
Then Linda.
I think an oxidizing agent is, these are elements which readily accept electrons in order to complete a full energy level, will possesses oxidation properties. And it possesses oxidation properties.
Okay, that is good, but like I said, we'll look at the electron bits later as we get to the further of these topics. But for now, I want us to really concentrate on removal of hydrogen and addition of oxygen. But that was a good answer. Thank you.
Then Kenneth, lastly.
According to me, an oxidizing agent is the substance in which oxygen is added to. That one is according to me.
Then from the chat, Edith says substance which transfers oxygen to another substance. Then Jerry says it is a substance which, okay, he says the same answer. Then Linda mute. Okay, so let me see. It's an element which adds oxygen or removes hydrogen from a substance. An oxidizing agent from Nora is a substance which transfers oxygen to another substance. That's it.
Okay, thank you all for those answers. But I want us to have more light on what an oxidizing agent is. When you're looking at soil erosion and you're looking at the agents of soil erosion, you're looking at those things that bring about soil erosion to take place. So those exact things are the ones that bring the soil erosion. So it's the same thing with oxidizing agent. So when you're looking at oxidizing agent, you're either looking at that component that causes oxidation or because when you're looking at addition of oxygen, that means oxygen must be a component there. So then removal of hydrogen, that element that causes the removal of hydrogen is what we call an oxidizing agent. For example, the equations we've looked at up there. What are the oxidizing agents we've had in those 5 equations? Who can tell us the oxidizing agents we've had in equation 1, 2, 3, 4, and 5?
Joel?
Oxygen.
Okay, thank you, Joel.
Claire in the chat says oxygen and hydrogen plus chlorine. Then Priscilla says oxygen.
Okay, thank you. I just want to go back to those equations briefly. So when you look at these equations here, you notice we've said an oxidizing agent is that substance that causes oxidation to take place. So for example, here we are adding oxygen. So that means since we are adding oxygen here, oxygen becomes the oxidizing agent because it's what is aiding the oxidation reaction. Then when you come here, still it's oxygen because oxygen is being added to copper. Then here still we have oxygen. And here there is something different. You realize that chlorine is removing hydrogen from the methane. That means chlorine becomes the oxidizing agent in that case. And then on the next equation, still you notice that oxygen is the oxidizing agent. Here. So here still you notice that oxygen is the what? Is the oxidizing agent. So it's very important to take note of those things. Remember in our keywords, we had the word oxidation and we had the word oxidizing agent. So far we have looked at those 2 keywords as regards our discussion.
In the chat, Joan Nichove says halogens and peroxide. Then another one was a different answer is Edith says non-metals.
Yes, all those depend on what kind of reaction you're looking at. So by the time you're saying non-metals, what kind of reaction is it? If it is a peroxide, true, because when you're looking at peroxides, it will split when exposed to, when it decomposes. So that means it will split into water and oxygen. So it depends on what reaction you're looking at for you to look at oxidation and then reduction. Okay. So we have other oxidizing agents. I'll request someone to unmute and read for us some of those oxidizing agents.
Shaba.
Okay, we have nitric acid. Then, concentrated nitric acid, concentrated sulfuric acid, potassium manganate, potassium manganate. Is it potassium for manganate? I don't know. Then potassium dichromate and hydrogen peroxide.
Okay, thank you. So we have nitric acid, we have concentrated sulfuric acid, and then we have potassium permanganate 7. This 7 is in Roman numerals, and then potassium dichromate and hydrogen peroxide. Of course, as we advance, we are going to see how we can write these equations and how they can bring about oxidation in different instances. Okay, so are we all good up to that part? Because now we are moving to the next phase of our topic today. Please, if we all good, may I get feedback? And if there are questions, let's take them so that we can move.
In the chat, let me see. Okay, we are good to go. Zero by is asking that you wait.
Sorry?
But it's okay, we can move on. I think you wanted to take a screenshot.
A screenshot of the previous slide? What?
Yes. Yes. Okay, it's okay. Yeah, then we can move on.
Okay. So, we are going to study the reactions below. So, our next phase is showing us these different reactions, and I want our comments on these reactions. What can we observe about these reactions here? When you look at them, what comes to your mind? What can you comment about them?
So, okay, if you want to submit, you raise your hand and then comment about the reactions.
Zeropa, I asked for your comments on the reactions. What do you think is taking place? What is happening with these reactions? Like we did with the oxidation bit, what is happening here? Someone to just give us a summary.
In the chat, Rina is saying hydrogen is acting as the oxidizing agent, then Preshi.
I think reduction is taking place, whereby I think because copper oxide, oxygen is being reduced from it and it's making water and copper, so reduction is taking place, I think.
Okay, thank you, Peshu. That is good.
Hand.
No, I think so. Most of the oxide is yep. I see that hydrogen is the oxide oxidizing agent there.
Okay, I didn't seem to get you. You can type your answer in the chat. Claire Mutima says loss of hydrogen. Joanne says the oxidizing agent is hydrogen. Then Shirabo Paul says oxygen is added to hydrogen to oxygen is added to hydrogen to form water, leaving the solid alone. Beth Sheba says copper 2 oxide has been reduced to copper and chlorine. To copper and chlorine, I think it's a mistake. I think it's copper to water. Then Purity says hydrogen is the oxidizing agent. Michael, formation of water plus solid as a product. Then oxygen and hydrogen are present as oxidizing agents from Zerupa. Then Macho says it's reduction. Hydrogen is acting as an oxidizing agent. Yes, that's it from the chat.
Thank you all for your contributions. Thank you, Ruth. So, unlike fast reactions, I want us to see what is happening in these reactions. So when you look at this fast reaction, obviously something is happening. You realize that we have copper 2 oxide reacting with hydrogen. This time round, hydrogen is being added to what? To oxygen. And in this case, oxygen is being removed from copper. So it cuts itself off. So does that bring something to us? Hydrogen is being added to oxygen. Oxygen is being removed from what? From the copper. So that means in that case we form copper solid and then what? Water. So in this case, we also have the same thing happening with lead 2 oxide. So when you have lead 2 oxide, you realize that hydrogen is reacting with the oxygen. That means hydrogen is being added to oxygen, while oxygen is being removed this time round from the what? From the lead, for us to form lead as a solid and then water. Then when we move to our third reaction here, we have iron 3 oxide in the presence of carbon monoxide gas. So when you look at this, you notice that we have iron 2 oxide, iron 3 oxide, sorry, with an oxygen on it. But this side, in the product side, you notice that iron is alone. So that means oxygen has been removed by carbon monoxide to give us carbon dioxide gas. So that means oxygen is being removed. In oxidation, we said oxygen is being added, while hydrogen is what? Is removed. But in this case, you notice hydrogen is being added and oxygen is being removed. So even when you look at the synthesis of ammonia, you notice that nitrogen is reacting with hydrogen. So that means hydrogen is being added to nitrogen to give us ammonia gas. So in this case, when you look at this, you notice that there is addition of hydrogen. Yet when you look at others, there is removal of what? Of oxygen. So those are some of the things you need to take into consideration. So having understood that, what kind of reaction is this? Is it a reduction reaction? Sorry, are these reduction reactions or oxidation reactions?
Before we go to that, someone in the chat is asking, does synthesis mean making?
Sorry, I didn't get that.
Is asking, does synthesis mean making?
Yes.
Okay, Michael?
I think the reactions are reduction reactions since oxygen is being reduced.
Okay, then from the chat, Charlene, Durable Paul says reduction reactions. Oxidation from Charlene. Sally Joshua, okay. Rovin, Julia says good. She says reduction. Then Bathsheba Ruth, reduction, treasure reduction reactions. Patience and Maureen, reduction reactions. Let me see. Linda is saying oxidation.
Linda,
Chiropal
even
reduction
after
as
that, we are still saying oxidation. Wow.
even Joan, Joanne is saying oxidation process. Kenneth is also saying oxidation. There are about 4 people who are saying oxidation. Then also Sally Joshua is also saying oxidation, but the rest are agreeing with reduction. Then someone whose gadget is dark blue says, teacher, where is addition of hydrogen in equation 4? Whereas Rodney is saying both. He's calling it a redox.
Okay, so when we are looking at these reactions, we have synthesis of ammonia. Someone asked in the 4th reaction. Here, you realize that this is hydrogen. And I know at least by now, if we have looked at more concepts, we know how to write equations. That is my thinking. So you have nitrogen plus hydrogen. Sorry, hydrogen is a 2. Let me just use a whiteboard. So we have hydrogen. We have nitrogen gas reacting with hydrogen gas to give us what? Ammonia. So you realize that this equation is not balanced until we balance this equation. So someone was asking, where is the addition of hydrogen? Here you're adding this hydrogen to the nitrogen to give you a reduction reaction. So for you to balance this equation, obviously we have 2 nitrogens, 2 hydrogens, then 3 hydrogens this side. That is why we put a 2 here. And then because the hydrogens have become 6 this side, to make sure that the hydrogens this side are also 6, we add a 3 so that we have 3 times 2 to give us the 6. So I don't know where the confusion is at that point. Dark blue, I can see your hand up. You want to ask your question again or?
Teacher, I wanted to know where is the addition of hydrogen in reaction 3.
Oh, in reaction 3, okay. So reaction 3, if I can reshare the other screen. If we are looking at, I said when we are looking at reduction, remember when we said oxidation, we said oxidation is the addition of oxygen to a substance and removal of hydrogen. So in this case, when we are looking at reduction, I expect that I have removal of oxygen, because now reduction is the opposite of what? Of oxidation. So I have removal of oxygen or addition of hydrogen. So that means one of the 2 can be happening or both of them can be happening at the same time. So when you look at this reaction here, I said when you look at iron 3 oxide, it has oxygen on it. But because it's reacting with carbon monoxide, which is a reducing agent, the carbon monoxide is going to take away the oxygen to give us carbon dioxide here. So that means carbon monoxide has removed the oxygen from the iron 3 to give us iron and carbon dioxide gas. Is that clear? For the person who asked the question. Please respond so that we can move. Okay, thank you.
He has responded.
Okay.
Kenneth is still confused.
Let him kindly unmute so that I can work with him while he's speaking and asking so that we can move to the next thing really.
Kenneth, unmute.
Welcome. Ochan, can you please unmute and tell me where the problem is?
my problem is
Kenneth, unmute. Aha, you're now unmuted. Please speak.
I'm confused in a way that I'm seeing hydrogen in the first equation. It's being, I'm seeing hydrogen is being what? As being added with oxygen to form water. So I'm seeing like it's an oxidation reaction because oxygen has been added to hydrogen to form water.
Okay, that is a very interesting question. But I want you to understand that when we are dealing with oxidation reactions, like I've seen, I think Talema in the chat is commenting about electrons. I said, let's first resist using electrons for now, because I want people to first understand this bit and then we can bring in electrons. And of course, as we go on, because you don't expect to give a baby meat to chew. They will not eat it, they will just leave it there. So we are moving from simple to complex. When someone understands these reactions, it will be easy for them to understand the reactions that don't involve oxygen, yet they are oxidation reactions. But if you haven't understood the reaction where I am adding oxygen, you may never understand the other bit. So that's why we are looking at those ones where there is direct addition of oxygen. So to come back to Ochan, when you're looking at these reactions, I don't want you to confuse them with the oxidation reactions. For example, the first reaction I had up there, let me just share the whiteboard here briefly. So when you look at the oxidation reaction I had, the first one, I had copper plus oxygen giving me copper 2 oxide. Is that clear? And I had
Yeah.
2 here, and I had that 2 there. So here you realize that I am adding oxygen. Oxygen is being added to a what? To another element to give me what? Copper 2 oxide.
Oxide.
But this time round, I have copper 2 oxide plus hydrogen gas to give me copper and what? And water. Plus water. So the difference here is coming in at this point. I do not deny the fact that oxygen is being added to what? To hydrogen. But this time round, remember, hydrogen is now the one being added because this sign is very important here. This sign here, you see here, we are adding oxygen. Here we are adding what? Hydrogen. Are you seeing that?
Yeah.
So this time round, hydrogen is being added to the oxygen and oxygen is being removed. Are you seeing that?
Yeah, I'm seeing.
So oxygen is being removed while hydrogen is being added. So in this case, because hydrogen is being added and oxygen is being removed, it becomes a reduction reaction. Are you getting my point now?
Yeah, I'm getting.
Yes, but in this instance where oxygen was being added, because it was oxygen being added to another reaction, there it became an oxidation what? Reaction. So are we now together?
Yeah.
Okay, so
in
I
the
don't want
chat,
us to run faster than ourselves, okay?
Yeah.
Edith is asking, Madam, your iron 3 oxide looks to be iron 2 oxide. She's asking for clarification on that.
Okay, iron 3, let me see. Oh, yeah, thank you. So that 3 is supposed to be on oxygen. Thank you for taking note, that is good. So the 3 is supposed to be here on oxygen, and the 2 is supposed to be here. Yeah, you're right.
Then someone is asking, sorry? Yes, someone is asking that isn't the carbon monoxide also oxidized to carbon dioxide?
Okay, so when carbon monoxide removes the oxygen from the iron 3, it is oxidized to carbon dioxide. But in this case, remember, it is acting as a reducing agent. Like, I'm going to ask us what is a reducing agent as we proceed. So of course it is because there is addition of oxygen, it is oxidized. But the reaction as in itself, because oxygen is being removed, it becomes a reduction reaction. I don't know if that answers the person's question.
Okay, they're using initials, so I really can't ask them, but okay, they've said yes. Rodney, you have a question?
Yes, I'm a little bit confused because I don't know, I have some different work on this particular topic. When I look at the reaction of copper to oxide plus hydrogen, according to what I learned earlier, it is a redox reaction. So I don't know, was I wrong or?
Okay, Rodney, I don't want us to move ahead of ourselves, but just for clarity, because I didn't want to confuse the rest, that's why I didn't want to talk about redox at this point until we get there. But because hydrogen is being removed and oxygen is being added, it automatically becomes a redox reaction. But in this case, where we are adding just hydrogen, because I want the rest of the people to be on the same page with us, just because we are adding hydrogen, it becomes a reduction reaction. But when we get to oxidation, because oxygen is being added to that hydrogen, it can be a redox reaction. Is that clear, Rodney?
Yes, it's very clear now.
Okay, thank you. Okay, so can we now move for now?
Yes, the rest had gone ahead to ask, how do you know something is a reducing agent? Then others had started giving their views on what a reducing agent is, like Bathsheba Ruth.
Okay, so that's our next point, and people will keep giving those suggestions. Okay, so we also have another one where we have a preparation of ethane gas where you're adding carbon and hydrogen to give you ethane. So that is also our reduction reaction. So in the first 3 equations, of course, oxygen is being removed from substances, while in the last 2, hydrogen is being added to the what? To the substances. So I'll have someone to read for us the definition of what reduction is.
Mackenzie?
Reduction is the addition of hydrogen and removal of oxygen from a substance.
Okay, thank you. So this and can always be or, so you can read it as is the addition of hydrogen or removal of oxygen from a substance. And like I said, if you are taking the screenshot or taking notes of those equations, you can now relate the definition where we are removing oxygen in the first 3 equations, and then in the last 2 equations, we are adding hydrogen. So that gives us what a reduction reaction is. Are we all good up to that point?
Enid, Priscilla, Saida. Okay, Vanessa, Saida, and Priscilla, your hands are up. Do you have any questions? If you don't have, you can lower. Priscilla, do you have a question? Or you lower your hand if you don't. Priscilla is not
Okay,
unmuting. If you can proceed.
thank you. So what is a reducing agent? Who can tell us what they know about a reducing agent?
Michael?
A reducing agent is a substance that causes reduction.
Okay, good, thank you. So according to the
Then,
equations we've looked at up there, Ruth, you are saying something?
no, it's okay.
Okay, according to the equations we've looked at up there, what are the reducing agents you can identify from those equations?
Phoebe? Okay, Phoebe, unmute. In the chat, Nancy says hydrogen. Then Joylyn says hydrogen, then carbon monoxide from Chernobyl. Then Joel, any other view if your hand is still up? Okay, that's it.
Okay, so of course, like we said, a substance that causes what? Oxidation. And of course, we had hydrogen and carbon monoxide in the equations above. So we have hydrogen and carbon monoxide both act as reducing agents in the above equations. Those hands that are up, is it that we have questions?
Michael, your hand is up and pretty. Eliana?
My question is, I'm so confused. How do you know something is a reducing agent?
Please, can we resist using the word confused? Because confused people can't really handle the chemistry we are studying. So let's use a better word, at least maybe ask for clarity, or maybe I've not understood this point. But if you confess the word confusion, it's not a nice thing to associate with it. Okay, so Eliana, I don't know where the difficulty is, but we have said, or maybe before I explain how I can identify a reducing agent, did you understand what an oxidizing agent is? Eliana, you can unmute and let me know.
Yes.
Okay, so if you understood, when we go back to these equations, I'll just take us back to that slide briefly. When you look at these equations, here, this one here, we are adding hydrogen. We are adding hydrogen. We are adding carbon monoxide. We are adding hydrogen. So something you have to take note of here. First of all, understand what is reduction. After understanding reduction as the addition of hydrogen and removal of oxygen, first of all, you need to understand if there is addition of hydrogen, that means the hydrogen becomes the reducing agent in that equation. And then if there is removal of oxygen, what has removed the oxygen from where it was? Like, for example, in this equation here, you notice that carbon monoxide removes oxygen from the iron 3 oxide to give you carbon dioxide gas. So in that case, carbon monoxide becomes the reducing agent. Does that make sense, Eliana?
Yes, teacher, it makes more sense now. Thank you.
Valid. Okay, thank you.
Then
Okay.
Freshie.
I'm saying, what if people are saying that the reducing agents are carbon monoxide? Why can't I just say carbon? Because according to the reactivity series, in the middle there of after magnesium and aluminium, we put carbon. Just and it's a bit more reactive than other elements, so it becomes somehow a reducing agent. So can't I just say that carbon, not carbon monoxide or carbon dioxide? Thank you.
Okay, who can answer, Pesh? Okay, so Pesh, look at this here. We asked what are the reducing agents in the reactions above. And this reaction has carbon monoxide, not carbon or carbon dioxide, as you mentioned. So we suggested that the reducing agents in these equations are hydrogen and carbon monoxide, because in any of these reactions, I don't see carbon dioxide anywhere. So you realize that in the reducing
Teacher.
agents, yes, please.
Sorry for interrupting. I think I've got her question. She's asking, why don't we use carbon? And I've understood. I think what Precious needs to do is to check out the definition of a reducing agent, because it is a substance but not an element. She is relating it to being carbon alone, since carbon in the reactivity series. And once you bring in reactivity series, you're now talking about an element. But any substance that causes reduction is what we call a reducing agent, not an element that causes reduction. So I don't know whether she has understood, Preshi.
I've understood it. Thank you. I've understood it.
Okay.
Okay, thank
Shall
you,
I try
Ruth.
to answer her?
Yes, but now when you consider those elements, look at hydrogen. Hydrogen is also an element. So it really has to matter with what equation, with what reaction you are working with. Because for you to even call carbon a reducing agent, it should depend on what equation you are working with. So it is really about what reaction is taking place and what is happening in that reaction. Is it reduction? Is it oxidation? If it is reduction, which elements are bringing about the reduction? So you really have to go back to the core of understanding what reaction is basically taking place. Okay, thank you, Ruth, for that response. Let's move on. Okay, so we have other examples of reducing agents here. Can someone read them for us?
Someone who has not yet participated yet. Jolene.
Carbon, hydrogen sulfide, potassium iodide.
You muted. Okay. Alf, where is your hand? What did Cesar see?
Examples of
Please read.
reducing agents, we have carbon, hydrogen sulfide, potassium iodide, and sulfurous acid.
Okay, thank you. So it's also important to understand that we have other reducing agents apart from the ones we've listed in the equations above. And some of those, of course, you can go back and read more because what we are giving you here is just to draw light so that you go and find more light. So please,
Before
everything
you
we
move
cover,
on,
you go back and read. Yes?
Teacher Martha,
Mm-hmm.
Teacher Martha,
Yes, I'm hearing you.
not oxalic, let me see. Acid also a reducing agent. Have you got me?
I just had reducing agent. I don't know what you
That
mentioned.
let me see the person who asked. Is it Tony Blair? Teacher, is anoxalic acid also a reducing agent?
Yes, it's. Of course, I said there are other examples and you go and read more about them. So as you read more about them, you come and add to your notes. This is not a final thing. And I'm sure also your teachers at school encourage you to go and find out more. So I just gave you some things that can give you some light so that you go and find more details to those things. So as you make your own notes, go back and read in other textbooks on the internet, what are some of other oxidizing agents, what are some other reducing agents, and also their equations, because there are very many others. Okay, Ruth, did I answer the person's question before we move?
Yes, you did. Han, please type your question in the chat so that we can proceed.
Okay, I'm seeing a hand up. Is the person having a contribution or a question?
I requested her to type in the chat. I'll read
Okay.
it out when she finishes.
Thank you. So, what are some of the importances of reduction and oxidation reactions in the chemical industry? How are those reactions important? How can you relate with them? In our daily life?
Rodney's hand went down. Okay. Priscilla? Namatari Priscilla, please unmute.
Can you hear me?
Yes.
They help in the respiration process.
Okay, do you mind explaining how?
Um,
Priscilla, unmute. Okay, I'm not sure if she muted intentionally. Then in the chat, Linda says making drugs. Then Nancy helps in obtaining gas. And Salma says, I think removal of oxygen helps to prevent rusting. Then Paul, your contribution.
I don't know if it's correct, but I think it is used when in mining. For example, when you mined copper, it usually comes as an ore, so it comes as copper ore. So like to remove that oxygen from the copper ore, like to bring out a pure metal after mining, I think they use carbon, and that's our a reduction reaction. Yeah.
Okay, thank you, Paul. That's the same as Rodney's answer. He talks about mining of copper. Then Experia says extraction of iron. Elijah says it helps in brewing industries. Then Claire says it's used in combustion, respiration, and corrosion. Ochan Kenneth says it helps in the preparation of substance in the industry like ethanol. And Tendo, lastly,
According to me, it helps in the formation of ammonia, which is used for making fertilizers.
okay. Thank you. Over to you.
Okay, thank you, Ruth. Thank you all for your contributions. They are really beautiful. So I can just add just a few hints here and there, but all your answers were really spectacular. So when you're looking at advantages of those oxidation and reduction reactions in our everyday life, they are used in very many things, and that is why you can't do away with chemistry. It's very, very key. So extraction of some metals, for example, iron and zinc, which involves reduction of their ores. So you realize that these metals are extracted from their ores, like we'll see in our next chapter, maybe at school or here during our lessons, if time allows. So, but of course you can still go back and read about them. So when you're obtaining these metals from their ores, you're going to use the reduction knowledge for you to obtain them from there or as in their pure state. And then, of course, we also have breakdown of food, for example, glucose to produce energy, which is an oxidation reaction. For some of us that are going to do biology, even at A level, you will see some of these equations and you will actually remember that, oh, this was actually an oxidizing reaction. So the breakdown of food in your body to produce energy is also a reduction reaction. And then, of course, most electrochemical cells, such as car batteries and dry cells, some of us who see the cars moving, that all the chemistry there to produce chemical energies as a result of both oxidation and reduction reactions. Like this one, we will do it under this topic when we are looking at redox reactions, where I was talking about the loss and gaining of electrons. So all that operates in that case, where you have the electrochemical cells. And then, of course, electroplating. I know you looked at this under rusting. So when you're making gold-based jewelry, of course, it involves reduction and oxidation. And this one, of course, also involves some bit of the knowledge of electrochemical cells. I'll expect us to go back and read about it. But even when we are covering the topic of loss of electrons as oxidation, we'll hint some bit of it because under there, we look at electroplating, where we use electrochemical cells of the cathode and anode. There is a lot of chemistry there that we'll look at. And then also hydrogen peroxide, which is used as an antiseptic. This one I didn't include it, but if you need it, you can write it. So hydrogen peroxide is also used as an antiseptic on minor cuts and burns to prevent skin infections. So it is also an oxidation reaction. So the fact that that hydrogen peroxide will act as an antiseptic and prevent infection on an open wound or anything, you realize that it is also as a result of an oxidation reaction. So basically, I think those are some of the few that we can come up with, but you can go and find out more really. Yeah, I trust that we have enough time to find out more of those importances. Okay, then I saw in the chat someone had written, is it combustion, preparation of ethanol? All those are some of the examples that we can actually relate with in that case. So, if there are no questions or additions, can we move on?
Then the additions in the chat, Shalini is saying used in making cosmetics, then ARV also medication. Then Brenda is asking for the meaning of ORs.
Can someone help Brenda understand what the word OR means?
Priscilla?
Ores are natural rocks which contain minerals.
Then Dark Blue is asking what of in catalytic converters. Then Trace is also asking what is meant by bot oxidation.
It was supposed to be both. Sorry about that typing error. I'll need to make some of those corrections after the lesson. Thank you for taking note, but it's supposed to be both oxidation and reduction. So ours is really from natural minerals. You're extracting these different metals from naturally occurring minerals. And like I say, that is the next topic in senior 4. So some of us who are still on more concept will need to first cover up all those topics, and then your teachers will look at this topic, and then you'll need to move to the next one. But there is no harm in reading ahead. It's always good to be informed. So you can go and make some research, and you will enjoy how those metals are formed. There even those notes are there in the old curriculum textbook, so you can keep referring to them, and then you're able to get there. Okay, so can we move?
Yes. Oh, this Dark Blue is saying what of in catalytic converters of cars.
Oh, catalytic converters, that's true. We also have reduction and oxidation taking place. If most of you can remember when we're looking at pollution and ways of prevention of pollution, you realize that we're talking about the iron, the lead, all those, the coppers, you realize that there is both oxidation and reduction taking place. Wow, dark blue, that is very good. So they are also used in catalytic converters, really.
Then someone is still asking, though I think we may not go there. She says, why is a reducing agent also defined as a substance that transfers electrons to another substance?
Okay, those are all good, but we'll have to look at those ones in front there. So just keep your question to them. And you never know, even as we look through the notes that day, your answer will come through even before you ask the question. Eh? I
Shamika, we
think
can go
someone's
on.
hand is up. Is it a question? Okay. Okay, so let's move. Uh, I just want to give us 1 minute to stretch a bit, think through what we've covered now, and then we can, after that, those 2 minutes, we can continue with what redox reactions are. Ruth, your mind timekeeper, when the 2 minutes are done, you can let me know and we proceed. I want people to stretch a
Okay.
bit and relax a little. Okay, so according to what we've covered so far, what are redox reactions?
In the chat, Claire sent that redox reaction is a reaction in which oxygen and in which oxidation and reduction occur simultaneously. Then Kadabra says redox reactions are reactions that take place with organic compounds. Then Michael.
Okay, redox reactions are reactions that involve both oxidation and reaction.
Lastly, Han. Han, unmute.
I think the reactions that occur in organic compounds. Thank you.
Indeed, your hand is up. Michael Blair.
Yeah, these are reactions that involve the transfer of electrons from one species to another.
Then Enid. Okay, then from the chat, Asim Marina says
Redox reaction is when oxidation and reduction take place simultaneously.
Then Zerupa. Okay, I think let's move on.
Okay, thank you, Ruth, and thank you all for your contributions. So when you're looking at redox reactions, you realize that the word redox is made up of two words. We have the read. We have the read and we have read and then ox. So we have ox and then we have read. So read is standing for reduction and then ox is standing for oxidation. So when you're looking at redox reactions, really we are really focusing on reactions that involve both reduction and oxidation occurring in those reactions. So like we'll see as we go on, people kept asking. So this is also another keyword that has been covered now. So you realize that we are now reducing the number of new words that we have. Okay, so read for reduction and then ox for oxidation. So when you're looking at redox reactions, that is where people kept talking about electrons. So we are now here. What is oxidation when we come to redox reactions? Who can tell us what they know about oxidation?
Rodney.
Yes, according to what I know, oxidation is the type of reaction where one substance or one chemical species loses its electron or its electrons to another.
Okay, good.
Rodney, please mute. Then Saida.
Oxidation is a process in which an electron is removed from a molecule during a chemical reaction.
Then Ravid.
Oxidation is loss of reactions
of electrons, sorry.
Loss of what? Of electrons, okay.
Han.
I had the same answer with her. Oxidation is the loss of electrons.
Okay, Linda.
Oxidation means the loss of electrons from a substance.
Claire in the chat says it's the loss of electrons during a reaction by a molecule, atom, or ion. And then Tracy says oxidation is loss of electrons. Okay, over to you, teacher.
Okay, thank you. So one thing that kept recurring in all your answers is the loss of electrons. So that means we understand what oxidation is. So when we are looking at oxidation, we are looking at the loss of what? Of electrons. And for example, when you were looking at bonding, you looked at loss of electrons. So I want us to quickly hint on that. What are some of the examples where we incur loss of electrons? Where are those? What are some of the instances where we find loss of electrons in chemical reactions? Did my question come out clearly? What are some of the instances that we interact with that involve loss of electrons? For example, when you are looking at ionic bonding, what are some of the substances that involved loss of electrons and then the other component gaining the electrons?
Charlene in the chat says magnesium.
Okay, we know that most metals lose electrons. So that is good. Any other?
Formation of sodium chloride.
Okay, good. Thank you.
Then Linda says sodium.
Okay, sodium loses its electrons. Okay,
For
so
iron,
okay, good.
for iron-free sulfate, that's from Rina. Treasure says aluminium. Julia says calcium. Eliana says calcium oxide formation. Xperia says iron oxide. Tugonza Joel says zinc. Okay. Then Dark Blue says metals lose non-metals, gain electrons. That's it. Blair says argon. Joylin says silicon. Ravin potassium, and etc. That's it. Okay, unfortunately, teachers jumped off due to network. Linda, your hand is up. The other group link shall be sent tomorrow, so just join in so that you can be able to be a part of the group. Let me see. And
The part was trying to explain what something electrons in order to gain stability or gain
And please type your question in the chat. Your network is not stable.
What she was trying
Please type your question in the chat. Teacher Martha, over to you.
So much, Ruth, for holding on the discussion. Sorry, my laptop had shut down because of battery. But we'll have to continue from where we stopped. So just go and think about redox reactions in terms of electron loss and electron gain. And of course, we can carry on from there. I'll share the slides with Mr. Kaziga and probably he'll share them on the group. So let's continue next Tuesday. Thank you all for attending and for your participation. I hope you are able to learn something. God bless you. Thank you all.
Okay. Anyone to lead us in a closing prayer? Thank you, teacher, for the lesson. Anyone who has not yet spoken? Jemima? Jemima, unmute.
Okay, let's pray.
Okay.
Dear Lord, we thank you so much for the lesson. Thank you so much for everything we've learned. Thank you so much for the things we haven't learned, but I pray so that we can be able to get them. Thank you so much for our teachers, and I pray so that we can have a blessed time. Please bless our teacher in Jesus' mighty name. I've prayed and believed. Amen.
And have a blessed evening, and let's meet tomorrow in the next lesson.